All right, so just quickly, a quick review about covalent bonding. So they form between nonmetal atoms. There's two types of covalent bonding. You got polar and nonpolar. So if it's nonpolar, the electrons are being shared equally. If it is polar, they're being shared unequally. The name of a compound that is formed covalently or bonded covalently is called a molecule. And I just want you to remember the covalent bonding is the sharing of electrons. Whether it's equal, it's nonpolar, unequal, it's polar. But they're being shared nonetheless. So one example would be fluorine. So fluorine is F2. It's what we call a diatomic atom, and we'll talk molecule. We'll talk about that later. But if we have two fluorines, fluorine has 7 valence electron. It's an halogen. And actually, I'm going to build it like this. And then another fluorine. So before, in an ionic compound, one would want to give up an electron, and then the other would receive that electron. But in this case, both of these fluorines are close to 7. Close to 8. So they both want to receive one electron, right? And the problem is if both want to receive and nobody's willing to give, you have a problem. So you have to come up with another solution. And remember, we're doing this in order to get to a full octet, right? A stable place, which is 8 valence electrons. So one thing that could happen is, let's imagine like this is the fluorine atom, and here's the other fluorine atom. Maybe I should have done a different color, but that's okay. So what they do is they say, okay, well, I'll share this electron, so we'll move that electron here, and then the other one's, okay, I'll share one of my electrons. So at this point, I'm going to just erase, oops. So in this particular, let me just use red. So this fluorine now, since they moved those electrons into, we'll just call it the sharing space, it now has 1, 2, 3, 4, 5, 6, 7, and 8, right? And then the other fluorine I'll do in, say, green, let's do in green. So it's got 1, 2, 3, 4, 5, 6, 7, 8. So by sharing a pair of electrons, these fluorine has now figured out how to get to a stable 8. They just kind of have shared ownership over those 2 electrons. And that's their way of getting an extra electron to get to a stable. And so the way we draw this is a shared pair of electrons is what we call a bond, a single bond. So 2 shared electrons equals 1 bond. So we would say if there's 1 bond, it would be a single bond. So here we have fluorine, 1, 2, 3, 4, 5, 6. So this is what it would look like. And so this line is a bond, which is really a pair of shared electrons. So hopefully that makes sense. So let's take a look at another one. So let's look at water. Oh, so they have 7 valence electrons, so they want to share their electrons, which is covalent bonding. So what does a water molecule look like? So water is H2O. So water is a little strange because it puts hydrogen first, but the most electronegative atom usually is the one that goes in the middle. So oxygen would go in the middle. And I'm just going to draw. So 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons. Hydrogen has... So the reason why I'm putting this like this is because these are already filled here, right? These 2 electrons. So there's no bonding that's going to happen. Where the bonding is going to occur is where there's an unpaired electron, right? Like you got one here and one there. And hydrogen has 1. So they'll want to share it. So what that does is the hydrogen will move their electrons closer, the oxygen will move it, so they'll share those pairs. Remember, hydrogen only needs 2 to be stable, right? Because it has only 1 energy level, and in the first energy level, you only need 2 electrons. So ultimately what would happen is these get shared. So ultimately oxygen will get 1, 2, 3, 4, and then they'll share a pair of electrons with hydrogen, right? And it'll look like this. So the hydrogen gets 2, which is stable, and then oxygen gets 8, which is what it needs. And then if we draw it with the actual bonds, so remember our bonds are going to occur here and here. So you got oxygen to hydrogen to hydrogen. And that's what water looks like. Okay? And then lastly, oxygen. So if we look at oxygen, oxygen is kind of interesting. So oxygen has 1, 2, let's do it this way, sorry. So let's go, I'm going to go in this direction, 2, 3, 4. And I'm just doing it so it's easier to show. Let me make another oxygen, say in red, so we can keep track of these. Okay. All right, so oxygen has 6, which means it needs 2 more electrons, right? So let's just start sharing. So say here is our sharing space, right, where bonding will occur. So we'll move one of these electrons to the middle. So let's say we move this one to the middle, and then we move this one to the middle. So what you'll see, let me make this smaller. So, okay. So, but if we count it, it's 1, 2, 3, 4, 5, 6, 7, right? And so it needs 1 more. So let's just share one more time. Another way to think about it is to get to 8, you need 4 pairs, right? So if you see some unpaired electrons on anything, then they need to be paired up. And so usually we accomplish that by sharing. So if we look here, if we count the yellows or anything in the yellow atom, we got 1, 2, 3, 4, 5, 6, 7, 8, right? We got 4 pairs, and then the same in the red. So oxygen has what we call a double bond because here's 1 pair, here's a second pair that's being shared, and then it has 2 unpaired, 2 lone pairs of electrons on each oxygen. So we call these lone pairs. So they don't participate in the bonding. They're happy. They're paired up, and so they're good to go. Okay. So this is So this is a double bond. Okay. All right. So sometimes atoms share more than 1 pair of valence electrons. So you can have a single bond, but if you have a double bond, that's when they share 2 pairs. A triple bond is sharing of 3 pairs. The more sharing that occurs, the closer it pulls the atoms together, and so the bond length would be shorter as you add more bonds, right? So like a single bond would be longer than a double bond, and a double bond would be longer than a triple bond. So the more bonds there are, the closer they get, and so the bond length, the length of the bond or the distance between the atoms gets shorter and shorter. All right. I'm going to stop really quickly and talk about the bonds. I'll add another. Slide here that'll explain further. But just something that we need to know is a single bond is what we call a sigma bond. So it kind of looks like this. So that's a sigma bond, and then any bond after. So, like the double bond is what we call a pi bond. So let me just give you an example. So for in our previous example, oxygen, right, has one sigma and one pi bond. So it has one sigma. So that's its. Here's the whatever first bond it was. That's what we call. So it has one sigma bond, and then it has one pi bond. And just so you know, if let's say we added a third bond, like a triple bond, it would be one sigma bond with two pi bonds. So a sigma bond is the first bond. So if you, in our fluorine example, we had a single bond. So there's one sigma bond, zero pi bonds. But as we add more bonds, then it has to do with, then you now have one sigma bond, and then you have a pi bond, and so on. And so the sigma and the pi actually have to deal with like the orbitals and how they overlap when sharing. And so there's an actual shape to it. But if you just remember that the first bond is always a sigma bond, and then any subsequent bond is going to be an extra pi bond. And I'll include a slide. I don't have one here during this time of when I'm recording, but I'll add something that I'll explain further. Okay. So there's something called diatomic molecules. So what they are they're just molecules that always appear in pairs. So di means two, right? And so here we have here are the 7 that are always diatomic, and some of them are bonded like remember this one is just a single bond, right? So only one sigma bond. And then oxygen has a double bond. And so you can always like figure it out. But you just have to remember when I say like hydrogen molecule or hydrogen, it's always going to be H2. And so the way I remember this is there's different things doing this. So one of them is like Hoff-Brinkel. So if you remember this, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine, those are the 7. And apparently Hoff-Brinkel, I don't know, you can remember it. There's another one. Let me just open up something real quick just to look at. Let me just open up a periodic table. Oops. So, the 7 are here in the halogens, and it looks like a 7. But if you look, it's 1, 2, 3, 4, 5, 6. So it looks like a 7, but there's only 6, and then hydrogen. So those are like the locations. And some people are like, oh, it kind of looks like a 7, starting at nitrogen and going to iodine, and then hydrogen. So however you want to do it, as Hoff-Brinkel or just memorize it or what have you, but just wanted to show you as well. Okay, so that ends kind of like this basic introduction to covalent bonds and molecules.